In this lab session, we will examine the results of an antimicrobial susceptibility test. Antimicrobial susceptibility tests are performed to determine the effectiveness of an antibiotic. Antibiotics are molecules produced by some species of bacteria and fungi that inhibit the growth of other bacteria. The first antibiotic was discovered in 1928 by Alexander Fleming. He noticed that a mold growing on Petri plates was inhibiting the growth of bacteria. He isolated the chemicals secreted by the fungus Penicillium notatum that inhibited the growth. You know that chemical as penicillin. Since that time, many other antibiotics have been discovered, and scientists have also synthetically produced antibiotics in the laboratory. Together, the naturally occurring, synthetic, and semisynthetic antibiotics are referred to as antimicrobials. Antibiotics have been used extensively since their initial discovery to treat bacterial infections. Unfortunately, there are many bacteria that have developed resistance to one or more antibiotics. I have found that many misunderstand the concept of antibiotic resistance. It has been my observation that many people believe that antibiotic resistance was a form of tolerance that the human body developed to an antibiotic. This is a very incorrect concept. It is important for you to understand that antibiotic resistance is the inability of the bacteria to be killed or inhibited by the drug. So it is the bacteria that is becoming tolerant. Bacteria may develop resistance to antibiotics via several mechanisms. We will explore some of the mechanisms of antibiotic resistance in Unit 4 of the lecture portion of this course. It is more important at this time that you understand that the development of resistance has made the selection of an antibiotic to effectively treat an infection more difficult. The development of resistant strains led scientists in the medical community to develop a means of testing susceptibility of bacteria to antibiotics to aid in the identification of an effective drug as early as the 1950s. Disc diffusion tests are performed by placing filter paper discs impregnated with known concentrations of antimicrobial agents on Petri plates that have been inoculated with a bacterial sample to form a lawn of bacteria. The drug then diffuses out of the disc into the agar, forming concentration gradients, with the highest concentration closest to the disc. Drugs capable of inhibiting growth will cause the formation of a zone of inhibition. A zone of inhibition is a clear zone around the antibiotic disc where growth has been inhibited. The zones of inhibition are then measured to determine the effectiveness of the antimicrobial agent. When performing a disc diffusion test, several factors may affect the size of the zone of inhibition. These factors include the molecular weight of the antimicrobial agent, the type of media, and the concentration of the bacterial culture. Early forms of disc diffusion test varied in regards to these factors, and as a result, different values were reported for the same antimicrobials, leading to confusion. In the 1960s, standardization of the disc diffusion method led to the development of the Kirby-Bauer disc diffusion susceptibility test. This standardized method of disc diffusion takes into consideration all of the factors that affect the size of the zone of inhibition and allows results from one lab to another to be compared. All aspects of the Kirby-Bauer test are standardized to ensure reliable results. The agar used in the Kirby-Bauer method is the Mueller-Hinton agar at a pH of 7.2 to 7.4. It is poured to a depth of 4 millimeters in 100 or 155 millimeter diameter plates. The depth of the agar is important because it affects how the antimicrobial agent diffuses through the agar. If the agar is poured too thick, the rate of lateral diffusion slows, making the zones of inhibition smaller. The Mueller-Hinton agar plates are inoculated with a specific concentration of bacteria. The concentration is visually measured by assessing the turbidity or cloudiness of the bacterial culture as compared to standards known as McFarland standards. The concentration used for this method matches a 0.5 McFarland standard. Discs containing known concentrations of antimicrobial agents are then placed on the plate. The plate is incubated at 35 degrees Celsius for 16 to 18 hours. The plates are assessed for zones of inhibition. Each zone is measured in millimeters and the values compared with a table to determine the effectiveness of the drug. The values determined from the zones of inhibition allow us to make a prediction of the potential outcome when the drug is used in a patient for treatment of infection. If it is determined that the organism is susceptible, it means that the concentration of the drug usually used is capable of inhibiting the bacteria, and that there is a good chance that the drug may work to treat the infection in the patient. If the result is intermediate, it means that higher than normal concentrations are needed to inhibit the bacteria. The effectiveness of the treatment with the drug is uncertain and would likely only be effective if the drug could be administered in higher than normal doses. A result indicating that the bacteria are resistant indicates that the organism is resistant in vitro, in the lab setting. So if it is resistant in the lab, there is a high likelihood that the use of the drug in a patient to treat an infection would fail. So we can see here that the goal of the susceptibility test is to detect possible resistance to an antibiotic. The diffusion susceptibility test is an important tool that aids medical professionals in the selection of an antimicrobial agent that effectively treats a patient's infection. Other tests would follow the susceptibility test to determine appropriate therapeutic doses. We will discuss some of these in Unit 4 of the lecture component. For our demonstration purposes, we will not be able to perform the Kirby-Bauer method due to the lack of some of the materials needed for the standardized method. We will be using nutrient agar for our diffusion susceptibility test. We also do not have McFarland standards to measure our culture against. The demonstration will allow you to get an idea of what the results would look like.